share that I have shared here?
Yes, sir.
Okay. So base theorem, before base theorem, we have to do total probability theorem. So what is total probability theorem? So I give you a case where there are many events in a sample space. This is a sample space, and in sample space there are many events like E1, E2, E3, dot dot dot, En. So a few things which you can observe in this sample space and these events, that all of these events are mutually exclusive. That means there is nothing common in between two events. It is not like this that we have E1 here and then E2 here. In that case, this is common. But the figure which I have drawn, there is nothing common between E1, E2, E2, E3, so on, E1, En. So you can say that any EI and any EJ, if you take their intersection, it is equal to phi if I is not equal to J. It means that events are mutually exclusive. This is the first condition. Then we have to also see here another condition. What is another condition here is that if you take the union of all these events, then what you will get is sample space, because nothing is being left in the sample space which is not covered by these events. So what we say that E1, E2, E3, so on, En are mutually exclusive and exhaustive events. The word exhaustive means that it is using the whole sample space. This second condition is exhaustive. So intersection of any two is null and union of all of these is sample space. So these are mutually exclusive and exhaustive events, right? Now, based on this, if you try to understand total probability theorem, so total probability theorem says, suppose we have an event A which is apart from E1, E2, E and so on. So if you take an event A and if you want to find probability of A, so what will happen is you can see that A event can have intersection with E1 or with E2, so on, with En, and you take union of all of these. So from diagram also I will explain it to you. Union of all this. That is probability of A. So you can see here that this event A has something common with E1, something common with E2. Similarly, if it is nothing common with E3, the intersection will be null. Something common with En, like this. So on, it is covering the whole A by taking common with any one of E1, E2, E3 till En. Okay. So it is sort of like you are covering A, this A, by taking common with E1, taking common with E2, so on, taking common with En, and taking union of all of this. So you are taking A like this. So can you write A like this? Hello.
Yes, sir.
Okay. Now, since E1, E2, En are mutually exclusive, so these events are also mutually exclusive. Their intersection with A are also mutually exclusive. So you can write it as P of A intersection E1 plus P of A intersection E2, so on, plus P of A intersection En. So union changes into addition. Now, PA intersection E1 can be written as PE1 into PA by E1. This can be written as PE2 by multiplication theorem, which we did yesterday, PA by E2, so on, PEN into PA by EN. So this is probability of A. So probability of A can be written like this. This is called total probability theorem. This expression here is total probability theorem. Sometimes question come from total probability theorem also, and mainly its use is in Bayes theorem, which we will study. So only thing is here is that E1, E2, En are mutually exclusive and exhaustive events. That is, there is nothing common between E1, E2, En pairwise, and all of them when combined will give you the sample space. So any event A can be, its probability can be found out like this. Now, when you see this, so what you can do is, now we come to one concept here in Bayes theorem, which you have to understand before starting Bayes theorem. Bayes theorem is little little difficult, not after understanding it, but when after you will understand it, it becomes easy. But before understanding it, it is little difficult to understand. So it can be understood like this, that there is a cause and there is an effect. So normally what we were doing is probability of cause when effect is given. Sorry, probability of effect when cause is given, like this conditional probability. So I'll give you an example. For example, there are two bags, one bag and two bags. This is bag A, this is bag B. And in bag A, there are 1, 2, 3 red balls. In bag B, there are 2 red balls. In bag A, there are 2 black balls. In bag B, there are 3 black balls. Now, if it is asked that what is the probability of getting red ball if bag A is chosen? So you don't have to think much. You will say that since bag A is chosen, this bag, so red ball probability is 3 upon 5. Am I right?
Yes, sir.
Similarly, probability of black ball, suppose, or red ball also you can say, when bag B is chosen. So here also it is given that bag B is chosen. Then what is the probability of black ball? So here black are 3 by 5. Coincidentally, both is 3 by 5. If you take red ball, it will be 2 by 5. Here you will take black ball, it will become 2 by 5. So this is the concept that if cause is known to us, if cause is known to us, Sorry. So if cause is known to us, then we can find the effect. But the question is like this, suppose that what is the probability of telling that the bag was bag A if the ball came is red ball. So red ball can come from both the bags. So now they are asking if the red ball has come, what is the probability that it has come from the bag A? Can you find out? If ball came is red ball. Okay, it can come from A also, it can come from B also. What is the probability that it has come from bag A? So here it is reverse. That is, the effect has already occurred, that the red ball has already come. And now the cause, that is the bag A is the cause, you have to tell its probability. So we can't tell it right now because we don't have any such straight way. Are you getting my point?
Yes.
Okay. So here the Bayes theorem come into effect. So when we say that probability of earlier what we were doing is probability of A by even, suppose in that set E1, E2, E3, I'm taking E4, E5, E6, E7, suppose 7 are there, and I'm taking a set A. So it has something common with everyone. It is not necessary that it is common with everyone something, but we have taken it. So it is common with E1, common with E2, then E3, E4, E5, E6, and then E7. So what is the probability of A when E1 has already occurred? So what you will do that if E1 has already occurred, you will write it as probability of A intersection E1 by probability of E1. And probability of A intersection E1 is this part. This part is A intersection E1, common part. So this probability you will find. And probability of E1, you know, that is this probability. This is E1 divided by this. This we will get probability of A by E1. So this is what we were doing earlier. That is, what is the probability of getting the red ball if bag A is chosen, or what is the probability of red ball if bag B is chosen. So that is PA by E1. Now here the question is reverse, PE1 by A. So what you will do in such case? So if you see that above example, the sample space is split into two events. This is one event E1, this is another event E2. E1 is choosing of bag A. E2 is choosing of bag B. So first, try to understand that these two events are here mutually exclusive, because if you choose bag A, you won't choose bag B. If you choose bag B, you won't choose bag A. And these are exhaustive because either you will choose bag A or you will choose bag B. Sample space. So these two conditions are there. So this is E1 and E2. Now, A is an event which says choosing of red ball or coming of red ball. So as we took above example that in bag A, 3 red, 2 blacks were there. So here 3 red and 2 blacks were there. Here 2 red and 3 blacks were there. So what is the choosing of red ball? So here comes the concept of Bayes theorem. So if you want to find P of E1 by A, that is what we were talking about, that if the red ball has come, what is the probability that it has come from the bag A? So write it as PE1 intersection A by PA. Now PE1 intersection A And PA can be calculated like this, that this is PA by E1 into PE1. This is PE1 into section A, as we studied yesterday also. And what is PA by total probability theorem? It is PA by E1 into PE1 plus PA by E2 into PE2. So here there are two, E1 and E2. So here the total probability theorem occurs in the denominator. This PA has to be written like this. Now PA by E1 is not a difficult task. A by E1 means what is the probability of choosing red ball when we have chosen the bag A. So red ball in bag A is 3 upon 5. We'll write it as 3 upon 5. And probability of E1, that is choosing of bag A, is half. Half bag A, half bag B. PA by E1 is again 3 by 5 into half plus PA by E2. So A by E2 is choosing of red ball when bag B has chosen is 2 by 5. So 2 by 5 into half. So this will become half you can take common and cancel. So 3 by 5 by 3 by 5 plus 2 by 5. 5 will also come common. So this will be 3 by 3 by 5. 3 plus 2, 5. So this will be your answer. Because 5 is the LCM, now it will get cancelled. So 3 by 5 is the probability that you are choosing if it is bag, if it is a red ball, then it has come from the bag. So the Bayes theorem actually states that if we want to find probability of E, probability of E I by A, so that is actually probability of A by EI into probability of EI. Either it can be E1, E2, E3 upon probability of A by E1 into probability of E1 plus probability of A by E2 into probability of E2, so on, probability of A by EN into probability of EN. So this is the Bayes theorem. Have you understood it?
Yes.
Okay. So we'll see a few questions on this theorem. So let us take question number 3 of this exercise 13.3. It says of the students in a college, it is known that of the students, it is known that 60% reside in hostel. So in a college, there are many students. Among them, 60% resides in hostel, and 40% are day scholars. That means they reside at their home, are day scholars. That is, they come from their home or PG, wherever they reside. They come for the classes only. They don't reside in the hostel. Now, previous year results report that 30% of all students who reside in hostel attain A grade. So it is said that 30% of those who reside in hostel, 30% of hosteliers, I think the spelling is right, hosteliers, it is said, get A grade. Is this the spelling of hosteliers? Don't know. And 20%,
Yes.
okay, and 20% of day scholars get A grade. So it is among total day scholars that 20% get A grade, not among 40%, among total day scholars. Matlab, that is total day scholar, not total student of the college. At the end of the year, one student is chosen at random from the college and he has an A grade. Now what we have done, we have chosen a student and he has A grade. So here it is being asked, I think you can think about the question. What is the probability that the student is a hostlier? Hostlier spelling is this actually. They have correctly written it later on. Hostlier studies. Spelling is here's A grade. And he has A grade. What is the probability that the student is a hostelier? Hostelier is actually hostelier. Okay. Student is a hostelier if chosen student has A grade. So would you try to do this or should I tell?
Oh, it's one from.
Okay. So first thing is to identify the mutually exclusive and exhaustive events. What are those? Give them their name. And then event A that you have to find out, which may be common with many.
Oh, so 9/13.
Okay. Let us see. So it will be okay. So probability of A grade when a student is a hostelier, 0.3. into probability of it being a host layer is 0.6. Here there will be same thing, 0.3 into 0.6. Here it will be 0.2 into 0.4. So you get here 18, and here you get 18 plus 8, 26. So 9 by 13. This is what you were saying, no? Hello?
Yes, sir.
Yeah, fine. So I think you can do questions now on base theorem. So just try question number 4, and then question number 5, and then twelve, 13. 4, 5, and 12, 13. Try these questions. I would tell you a simple method also, where your lot of energy in writing will be saved. So what you can do here is, you can also take the start like this, and you can say that these are the branches when you start it. This is event E1, this is event E2, so on, E3, E4. And this event will give you A. This event can also give you A. This can also give you A. This can also give you A. So you make a tree diagram like this. And after making the tree diagram, find this probability of E1, this probability of E2, this probability of E3, probability of E4. It depends how many E1, E2, so on are there. So keep on writing like this. This will be probability of A by E1. This will be probability of A by E2, probability of A by E3, probability of A by E4. So it is sort of T diagram. Now, if you have to find, suppose, probability of E2 by A, so you don't have to think too much about writing. But if it is a step marks and big, mm, 5 marker, 4 marker question, then you have to write the steps. But there is a method of tree diagram also. So what you will do, you will multiply this branch value with this branch value. You just multiply them and write it in the numerator. And in the denominator, similarly multiply this branch value with this branch, and then add with second one multiplication, then add with third one multiplication, then add with fourth one multiplication, and so on and so forth. In this way, you will get the answer. Are you getting this concept?
Yes.
So this tree diagram method is also very helpful in minimizing the calculation and understanding the concept easily. I'm coming in a minute, Darnell, while you are doing. Do you have any question to ask right now?
No, sir.
Yes, Darnell. What's the status?
So I'm not sure to do the 12th one.
Okay. Can you see the answer for fourth and fifth one and check if it is right? We won't discuss it.
Yes, that's right. Yes, that's right.
So 12th one. 13 ones have you tried?
No, sir.
Okay, so 12th let us discuss first. Then you will try 13th one. A card from a pack of 52 cards is lost from the remaining cards of the pack. Two cards are drawn or found to be both diamonds, and the probability of the lost card being a diamond. So again, tree diagram is quite helpful in such cases, in all cases of base theory, in fact. So what happens, then you start the experiment and you have two mutually exclusive independent events. What are those two? So, so one event you can take that the lost card is diamond. Okay. And another event you can take, lost card is not a diamond. So if you will see the probability of these, diamond are 13 out of 52. So 13 by 52 is the probability, that is 1 by 4. And here it is 3 by 4. Now we come to the final one, which says the two cards which are drawn are found to be both diamonds. Two cards drawn are diamond. So here if you will see the branch value. So lost card is a diamond. So how many diamond are remaining? 12 diamond are remaining. Out of 12, you have to select 2 in 12 C2 ways. And total number of ways of selecting is 51 C2. Because 51 is total. Is it okay?
Yes, sir.
And here lost card is not a diamond. So it is 13 C2 upon 51 C2 because still there are 13 diamonds there. And when you will find the probability of the lost card being a diamond, so which branch you have to take in the numerator? This branch. So 1 by 4 into 12 C2 by 51 C2 upon 1 by 4 into 12 C2 upon 51 C2 plus 3 by 4 into 13 C2 in divided 51 C2. So this is how you will write it. Now 4 will be cancelled and also 51 C2 will be cancelled. You will get 12 C2 here and you will get 12 C2 here and here we get 3 into 13 C2. So when you calculate it, 12 C2 is 12 into 11 by 2. So it will be 66. Here it will be 66. 13 is 13 into 12 by 2. So 13 into 6. 6, 3, 18. 1 carry. So it will be 13 C2. 13 into 6, right? 3, 6, 18. 1 by carry. So 6, 78. Okay. Into 3. So you'll get 66 by 3 into 78 is 8, 3, 24, 2 carry, 224 plus 66 it will become. So it will be 66 by 0, 1 carry, 9 to 290. So this would become 33 by 145. Can you check the answer from that? 33 by 145 it is. For 1 second. What is happening? It is 33 by 145. The answer is 33 by 145. Can you check from the back?
So the answer is 11 by 50.
11 by 50.
Yeah, 50.
Okay, so let us see the calculation part. This part is fine, I think. Diamond are 13 now, okay. And it is 13 C2 by 51 C2. It is also fine. So 12 C2 by 12 C2 plus 3 into 13 C2. 13 into 6. 78 into 3. It will be 12. 6 into 11. 66. It will become 66 by 66 plus 4, 8, 3, 24, 2 bacha, 3, 20, 24. Oh, some calculation mistake is there. This 234. 8, 24, 2 carry, 21, 22, 23. So this 234. So this would become 300. So this will become 33 by 150. Or you can also divide by 3 also. You can divide by 6 actually. So 6, 11 is 66 and 650. 11 by 50 you are saying now?
Yes, sir.
Yeah, fine. Here it was 230.
So I didn't understand the 12C2 and 13C2 part.
It is the number of ways in which we select our object out of n object. In permutation combination, we used to do this now. If n objects are there,
Yes, sir, but how is it 12?
because one card which is lost is diamond. So how many card is left of diamond? 12 is left. From 12, you have to select 2. So 12C2 is the total number of ways of selecting from diamond. And out of the total cards, 51, you can select 2 cards in 51 C2 ways. So this is how the probability we find. Number of favorable ways by total number of ways. Here it was 13 because lost card is not a diamond. So all 13 cards are before us. So you have to select 2 cards of diamonds out of 13 cards in 13 C2 ways. Okay.
Yes.
And NCR formula also you remember n factorial by r factorial into n minus r factorial. Now you can try question number 13 also.
So I'm not able to do the 13th one. So
Okay. So I'll give you an initiative and you can try, because it is sometimes difficult to analyze the events, because which event to be taken. Mostly we get confused in taking E1, E2, so on, these events, which are actually mutually exclusive and exhaustive. So it says property that A speaks truth is 4 by 5. A coin is tossed. A reports that a head appears. The probability that actually there was head is. So probability that A speaks truth is 4 by 5. So what is the probability that he speaks false or lie? That is 1 by 5. Now a coin is tossed. A reports that a head appears. Now A reports, it is head or not head, we don't know. But actually it is being reported by A that head appears. It is being reported like this. So let us not write probability here. Reported by A that head appears. The probability that actually there was head. So you have to take the help of again tree diagram that will help to understand the question. So experiment starts. If experiment starts, what will happen? Will he tell lie or truth, or first the output will come? What will come? First, either head will come or tail will come. Then only he will be able to tell. Na? Before anything coming, he won't be either telling truth or false. Now, it is being said that he reported head. So, what is the probability of head? It is half. What is the probability of tail? It is half. Now, what is the probability of reporting head when head will come? Can you tell me? When head will come, yes?
So the probability that A speaks truth over the amount of times A speaks truth when it's high.
Your voice is a little low. Something I've heard, but not all the things.
So the probability that A speaks the truth over or the probability that head appears if A speaks the truth.
Yeah, so this is 4 by 5. And if tail will come and he reported head, that is 1 by 5. That is speaks lie or false. Now it is being asked, what is the probability that actually it is head? So you will take this branch, half into 4 by 5 upon half into 4 by 5 plus half into 1 by 5, another branch. So it will become 4 by 5 into 10 will cancel and you'll get 4 by 5 as your answer. And check also that the answer should be option A. Just check from the back.
Oh yes, so it's option.
Yeah, it is coming. So let me give you few more questions, not from the NCRT, from elsewhere. So you'll be able to do on Bayes theorem. Because this is a very important topic and there is more than 50% chance that a question will come on Bayes theorem. So I'm sending them on chat. It will take a while, but I'll send them. I've selected the questions. One second, a call is also coming. Yes, let me download those questions, then I'll share on chat. Yeah, I have sent you the questions. There are two questions there. First, try these two questions. Have you got them?
Yes, sir.
I'm coming from washroom in a minute. Yes, Darnell, were you able to do these questions?
So for the first question, I got
Hello?
yes. So for the first question, I got 0.072 by 0.167.
0.7, let me write it. Which question number are you talking about? Question number 10 or question number 3?
So question number 3,
Okay. So can you tell me again what is the value?
0.072 by 0.167.
So it is actually 72 by 167, right?
Oh
Okay.
yes.
So let's see. Question was, in a neighborhood, 90% children are falling sick due to flu and 10% due to measles and no other disease. The probability of observing rashes for measles is 0.95 and for flu is 0.08. If a child develops rashes, find the child's probability of having flu. So if the child develops rashes, what will happen? Either he will have flu or measles. This is the first step. And then he will have rashes. And flu is 0.9, measles is 0.1. Rashes for measles is 0.95. And for flu is 0.08. If a child develops rashes, find the child's probability of having flu. So 0.9 into 0.08, and here it will be numerator, you are getting correct. It will become 0.072. Fine. And denominator, you will get 0.072 plus 0.095. So that would become 760. Yeah, fine, correct. Let us do the next question now.
So for question 10, I got 21 by 43.
21 by 43. 30 tin pure ghee and 40 tin adulterated ghee are kept for sale, while in shop B, 50 tin pure ghee and 60 tin adulterated ghee are there. 1 tin of ghee is purchased from one of the shops randomly and it is found to be adulterated. Okay. So B shop probability is half and shop A is half. That half will go away. Now from B it will be 50 adulterated. So 60 by 100.6 or 60 by 110. Okay. So 6 by 11 it would be. Let us calculate it. 6 by 11 it would be here. And then here it will be 6 by 11 plus 4 by 7. So you will get 6 by 11. It will be 77. 42 plus 44. 86. 42 into 21. 43. We are getting this. This is what you said?
Yes.
Okay. So it is correct. Now, do you have class tomorrow also? We will complete this chapter tomorrow. Only one thing is remaining. So, do you have class tomorrow?
Yes, sir.
Okay, let me see in the syllabus what else they have given. They have given, we need to check. Random variable and its probability distribution. Okay, mean of random variable. So they have not given Bernoulli's trial and all. They have removed Bernoulli's trial. Have they taught in school?
So I didn't attend school when this chapter was taught.
Because they are not talking about Bernoulli trial. Let me see exactly what they have skipped in this syllabus. Random variable and probability distribution, that's fine. And then we have mean of a random variable. Variance also they have skipped in this. And also Bernoulli trial. Okay, so only next exercise is there in your syllabus, which is 13.4. After that, Bernoulli's trial and binomial